Ever heard of an earth scraper? Picture this: buildings that don't soar into the sky but plunge deep into the ground. Earth scrapers are turning urban architecture on its head, quite literally. They offer a fresh solution to the challenges of urban growth and sustainability. But what exactly are they? How do they work? And why are they becoming such a hot topic? Stick around to find out. This revolutionary concept might just change the way we live in cities forever. So, what is an earth scraper? An earth scraper flips the idea of a skyscraper on its head, going underground instead of up. Also known as an inverted skyscraper, this concept has been around since the 1930s. Originally called a depth scraper. Imagine a structure that defies our typical understanding of building design, creating living spaces beneath our feet. Sure, we have underground parking and shopping areas, but they don't quite qualify as earth scrapers. True earth scrapers start at the surface and extend deep into the earth. However, it's important to note that this idea is still mostly theoretical. The potential for these structures to reshape urban landscapes is immense, sparking curiosity and debate among architects and city planners alike. The first earth scraper concept emerged in 1931 due to Japan's frequent natural disasters, especially earthquakes. Their proposal was a 35-story cylindrical structure with a metal framework and armored concrete. Unfortunately, this ambitious idea never came to life. Despite its failure to materialize, it laid the groundwork for future innovations in subterranean architecture. A more modern concept, the Zocalo earth scraper, was proposed by BNKR, an architecture firm, in 2012 for the Ivolo skyscraper competition. Due to height restrictions in Mexico City's Central Square, they envisioned a 65-story building descending 1,000 feet underground. It would have 35 floors of offices, 10 floors for housing, and the rest for retail and a museum, all under a glazed roof for natural light and ventilation. This design highlights the versatility and practicality of earth scrapers in modern urban environments. And now the question: why earth scrapers? As our global population grows, it's estimated that by 2050, 68% or 6.68 billion people will live in urban areas. We need more space for commercial and residential buildings, but we're running out of land. Earth scrapers offer a clever solution by providing additional space without taking up more surface area. This approach could revolutionize how we think about urban density and land use, making cities more efficient and sustainable. Global warming has caused unpredictable weather patterns, but underground, temperatures remain stable. At just 1 meter below the ground, temperatures fluctuate by only 5 degrees Celsius daily, and at 5 meters, they vary by just 1 degree Celsius. This stability is a significant advantage over traditional buildings. Not only does this make for a more comfortable living environment, but it also reduces the energy needed for heating and cooling. Building skyscrapers requires substantial materials and support to withstand storms and winds. Earth scrapers, on the other hand, use the earth itself for strength and stability. They also offer better protection against cyclones and tornadoes, unlike their above-ground counterparts. This inherent resilience makes them an attractive option for regions prone to severe weather. Earth scrapers are a fascinating glimpse into the future of urban living, combining innovative architecture with practical solutions for our growing world. With the potential to transform cities globally, they represent a bold step forward in sustainable development. However, earth scrapers are not without their challenges. Imagine a world where we live not just above ground but also beneath it. Enter the concept of earth scrapers. But before we get too excited, let's dive into the challenges these underground marvels might face. First off, the ground beneath our feet isn't just dirt, it's packed with minerals and natural resources, some of which emit radiation. Building earth scrapers in these areas could expose residents to harmful substances. To avoid this, we'd need to carefully select construction sites, steering clear of these danger zones. This meticulous process would demand both time and resources, posing a significant challenge for developers. Our current skyscraper infrastructure is designed for efficient sewage and water drainage, but earth scrapers would require entirely different systems. These new systems would need extensive research and careful planning to avoid costly mistakes and wasted resources. This unique engineering challenge of earth scrapers demands advanced techniques like reinforced concrete, soil nailing, and deep soil mixing to ensure structural stability and safety. Additionally, sophisticated drainage systems are crucial to managing groundwater seepage and preventing flooding. The idea of underground living isn't entirely new. Take the ancient underground city of Adarankü in Turkey, built in around the 8th century BC. This subterranean habitat housed thousands of people and included homes, stables, wineries, and chapels, proving the viability of living below the surface. As urban populations grow, construction industries are rethinking its approach to create a sustainable and profitable future for city dwellers. Innovative designs like Earthscrapers, ground scrapers, and ocean scrapers are being explored as solutions to the space crunch in crowded cities. Just as skyscrapers once seemed impossible, the drive to innovate has turned far-fetched. Ideas like airplanes, spaceships, high-speed trains, and submarines into reality. If Earthscrapers come to fruition, they could revolutionize city planning, creating new living and working spaces where building above ground is no longer an option, potentially reshaping the future of urban design and infrastructure. Let's take a look at some projects already in the works. In Mexico City, a major Earthscraper project is ongoing. Singapore began an Earthscraper project in 2008, with its first phase completed that same year and the second phase in 2017. This 60-meter deep Earthscraper is expected to be fully finished by 2026. In New York, the Low-Line project aims to transform an abandoned subterranean trolley terminal into a vibrant public space. This Earthscraper will use advanced technology like solar collectors and fiber optic cables to channel sunlight into its depths, creating a lively underground oasis. Despite facing financial difficulties, the project showcases a creative approach to urban space utilization. Montreal's underground city, Réseau, is a prime example of successful underground development. Spanning over 20 miles, this network includes shopping centers, offices, hotels, museums, and public transit hubs. Since its inception in 1962, it's become a popular tourist destination, attracting around 500,000 visitors daily. The climate-controlled environment provides a comfortable refuge from the harsh winters, proving that underground spaces can be both functional and attractive. Earthscrapers hold promise beyond residential and commercial uses. Imagine underground hydroponic farms thriving in a controlled environment, conserving water and providing optimal growth conditions year-round. Data centers could also benefit from the natural insulation and geothermal cooling capabilities of Earthscrapers, reducing energy costs and improving efficiency. Looking even further into the future, Earthscraper technology could play a crucial role in extraterrestrial colonization. In 2017, a team from MIT won the Mars City Design Competition with their Redwood Forest concept, envisioning interconnected Earthscrapers on Mars. These subterranean habitats would protect residents from harsh surface conditions and cosmic radiation. Perfecting Earthscraper technology on Earth could pave the way for creating sustainable living spaces on Mars and beyond. The Earthscraper concept represents a forward-thinking approach to urban development, offering sustainable and innovative solutions to modern cities' challenges. By building downwards, we can create efficient, environmentally friendly spaces that preserve the natural landscape and improve urban living conditions. As technology advances, Earthscrapers could become a common feature in future city planning, reshaping our approach to urban growth and development. Now that we've dug deep into the world of Earthscrapers, their potential benefits, and the challenges they face, what do you think? Could this fascinating idea become a reality? And if so, how long do you think it will take for Earthscrapers to become part of our urban landscape? Share your thoughts in the comments and don't forget to subscribe for more intriguing insights. Thanks for watching.